Awesome. So if you're able to tune in to the live presentation mode, and this is a Flat Earth Friday Twitter Space exclusive here, if you click on my profile name, you'll see that I'm streaming, and you can pull that up, and you can leave the Twitter Space open in the side, so you'll still hear everything in real time. Just mute the audio from the video, and you can just watch and follow along because this is a main interactive thing a little bit. So what we have here is the old glob with 2 clocks on it, 2 atomic clocks. These are noted by mechanical clocks. Couldn't find any good images for an atomic clock. But anyway, we have a satellite up here, and he has a clock on him as well. So we'll get to that in a minute. And then we have the sun over here. So let's take a daily sample of where the Earth would be, and then with respect to its orbit around the sun. And we have a clock facing the sun at noon, and we have a clock on the other side of the Earth facing away from it. So this is midnight and noon, right? And then we have the sun exerting its gravitational potential as a gradient through all of space, essentially, right? Relative to where we're at. And that the density of that gradient changes at the distance from the side that's facing the sun versus the side that's away from it. It'd be, I think what did Stone say earlier, like 8,000 mile difference, right? So there's going to be a different density layer to that gravitational potential, right? And that's going to require specific corrections, meaning that when the clock is facing the sun, it's going to be retarding more because it's in a denser gravitational field. So that oscillation rate's going to change. Earlier when I was talking about the guitar string and how it oscillates at 300 million times a second. So you can still apply that to make it easy. So just suppose these clocks work off of a 300 million oscillation cycle. When it's facing the sun, it should oscillate way less, and it should be in accordance with the sun's gravitational field, like its strength relative to the distance that we are from it. And they should be able to calculate that. This should be incorporated in all atomic clocks. This should be, it's called the midnight noon problem. And this was put forward in the 1980s, and it was reviewed and corrected by the big GPS guy. If you start looking into GPS and relativity, you're definitely going to come across the guy named Neil Ashby. This is the relativity GPS fixer. He gives all the all the quote unquote general relativity corrections and whatnot that makes general relativity and GPS work together. But anyway, that guy messed up the math a little bit, and it was pointed out a couple years later by Ron Hatch that he did the math wrong, and that there isn't any. I'm sorry. Neil Ashby did the math and said that they don't expect any gravitational redshift or whatever. That was his way of canceling it out. And then Hatch came by and was like, no, it's definitely should be there. Here's the strength, what it should be, et cetera, et cetera. You didn't do it right. It's not a prediction of you, right? So what had happened is that Neil went to go publish his paper on or refuting the original midnight noon redshift guy, and Hatch was going to submit his to the same person that that Neil was publishing his paper in, and Neil withdrew his paper because that guy wouldn't decline, or he wouldn't exclude Ron's paper from being included with his because it directly refuted his. So he pulled his paper from the publication and then published it elsewhere, and then acted like, Ron, he never heard of Ron, dog. Did him dirty, dude. Couldn't stand on his own paper, dog. So if I don't know how the math worked out, but I can tell you, if I had math that was going to be in a publication and some guy was going to refute it, and I wasn't aptly able to refute his math, I would definitely do the same thing and pull my paper and run and hide, right? That's crazy. So anyway, this is a prediction of their model that the clock should change in proportion to that strength of the gravitational field, because what they say is that on Earth, the strength of Earth's gravitational field as a clock moves away from the surface of the Earth, that gravitational potential changes and actually requires corrections in it. So it's like, oh, okay, cool. If that's true, then the sun, which is at the distance that we're at, is exerting 2.2 times the gravitational potential as the Earth is on the moon. Then how could it be possible? How could it be possible that there isn't a correction required as we're as these clocks are rotating through a gradient that's changing based off of like how far away they are from the source of the gradient, right? So this is a huge falsification to the concept of big G that they're applying to the motion of the solar system and the sky. Everything that moves in the sky is in accordance with big G. Well, big G has effects that would have to be manifested in reality for them to, for that equation to be meaningful, right? For it to apply a dynamic explanation to the motion in the sky, if mass is attracting mass in such a way that it's causing the Earth to move towards it, then it's also going to cause clock retardation in proportion to that strength. Now, if you flip that and do, well, no, it's just the old Newton, blah, 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 he was wrong, we know general relativity. Okay, cool, that's even better, dog. So now you're going to use the same big G coefficient, distributed the same exact way, and have the same issue, but have it be due to the bending and warping of space-time, but you're still in a gravitational field with that density to bend and warp space-time around you. So you're still going to need that clock to retard proportional to that, regardless of Newtonian mechanics or Einsteinian mechanics. So that's a wrap for that. Let's see, was there anything else I wanted to add to that? Newtonian? Yes, Stone added another thing that was hilarious too. So in addition to the daily rotation, right, where these clocks will be on opposite sides of each other facing the sun, so they'll be getting different layers of that gradient. Well, as the Earth is moving through, through space around the sun throughout the year, guess what, boys? It's going to get closer. Actually, no, it stays the same distance, doesn't it? So that wouldn't apply. So it would just be daily rotation. Okay, well, no. They say it gets 3 million miles closer because it's an ellipse. So, yeah, actually, when it gets closer throughout the year, yeah, when you're closer to that, what is that, aphelion? No, when you're perihelion, you're going to be experiencing the most clock retardation because you're closest to the sun. You're going to be you're closest to that gravitational field. Guys, there's no annual corrections that have to be made for atomic clocks on either side of the Earth throughout the year. It's not a thing that they account for. And this is an actual mechanic that is within their means to have to account for, right? Like, this isn't just like, oh, it's not sensitive enough. No. It's specifically sensitive enough for that. And this is one of the things that they don't account for. If they're telling you that, oh, dude, if you move this clock 10 feet off the ground, that's going to change the gravitational potential, dog. You're going to have to correct for that. Okay, cool, bet. If I'm facing the sun and then I'm not facing the sun because the distance between us has changed by, 8,000 miles, well, we're definitely going to have to correct that clock, right? So, well, no, it's different. Okay.
Can I get in? What I was talking to you about was, it sounds like you and Witsit kind of take like Einstein and you take a lot of mainstream science, but then you twist it, you editorialize it at the end and somehow infer that it's not true. But like, are you guys disproving it? Or are you just saying like, oh, the 2.2, like, oh, it's just too much, it couldn't be true? I mean, like, you say 95% mainstream science, you guys do, and then you kind of twist it. So what's up with that?
I think you're confused here, my boy. The sun,
yeah, I think you're hopping
the sun, they say, is exerting a certain amount of gravitational force, right? That's producing all the motion that we see in the sky, right? Regarding our solar system, of course, right?
Yes, everything revolves in the heliocentric model around the sun, correct?
Okay, cool. So, are you aware of the concept that they say that light retards in a gravitational field, right? Due to the strength of the gravity.
With the inverse law as well, squared law? Like it with
this isn't an inverse issue. This would be a oscillation rate issue. So kind of like how light slows down in a medium. So this would be essentially saying that light's traveling a little slower in the gravitational field, essentially.
Okay, and then you just don't believe that, is what you're saying. You said all those things.
No. It's not what I said. So what I said is that there's a specific prediction that's made based off of the physics that are introduced, right? So they say that the dynamic cause of everything moving is mass attracting mass, blah, 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 right? So that's in the strength of this gravitational field is doing all this, right? So that's going to have to produce certain effects that will be measurable here on Earth. Now they say that they have atomic clocks, right, which require very specific corrections to maintain an oscillation rate so that they can keep time. And they say that when a clock is taken to altitude, they have to make corrections to account for the difference in the gravitational potential relative to a clock on the surface of the Earth, right? So they're invoking like a density gradient to the gravitational potential, right? That's an easy way to look at it, right? And when the way that they do the math, the way that they make their corrections, they're only basing the correction off of whatever the potential would be from the Earth, from just that, right? Now they're completely excluding the gravitational field of the sun, which would absolutely be a relative factor in it, right? If they're going to go so far as to say is that even when you move a clock 10 feet off the surface of the Earth, there's a gravitational potential change in that, and that they can measure it. It's like, okay, cool. If it's sensitive enough for that, then why don't you have to account for the gradient from the Earth's gravitational field as well? Because if you're on a ball that's rotating, right, when it's noon, you're going to be closest to the gravitational field, so that clock's going to be experiencing more of the gradient. You're going to be more retardation. When a clock is on the opposite side of the Earth at midnight, it's going to experience less retardation because it's further away from the gravitational field. It's not as strong, right? So there'll be less retardation. So they would have to come up with a mechanism to compensate for the difference every day while our Earth is rotating. And in addition to that, if the Earth gets closer and further away from the sun, right, if that 93 million mile distance changes, well, you're also now closer to the gravitational gradient annually, right? So that's going to have to be corrected for too. And that's not something they account for. What I'm saying is the implication just off of that is that the Earth is stationary, and the things that they apply to the causal mechanisms of the motion in the sky, which is big G, mass attracting mass, and then later converting that big G into a distribution of bending and warping of space-time. But either way, there still has to be an effect measured here on Earth to correspond to that gravitational field, and no such correction exists. So I'm going to deduce from that because it doesn't exist, doesn't need correcting for, it's because it's not a real factor that.
Well, explain.
This is where the archive potential needs to be implemented too. So now that this is the case now in history, what if we get wind of this and this becomes popular because, not many people dive into the mechanics of GPS, etc. And let's say years from now, they need to start putting things in the manual and says, oh yeah, we totally do correct for it. Or let's put a line of code that says we correct for it. But do you see something like potential of that happening in the future, Alan?
No. If it was something relevant, like the thing with these corrections that I noticed is that there's an engineer out there, like if it's in the code to be corrected for in that regard, there's an engineer out there that like measured it and had to figure it out to put it in there. There's nothing in there that isn't just to make shit up. The only thing that would be in there to make shit up would just be like the scale invariant side to get the distances to correspond to what they give us when we use GPS ourselves. And we're like, oh, look, that satellite must have been 50,000 kilometers out. Now through scale invariance, it could be much closer. And that's it.
So are you a geocentric globe earther then? That would be kind of the deduction I would make.
No.
Really?
I don't believe satellites are free falling around the ball. I think there's another mechanism for them, and they're just above us.
But I'm saying, like, I'm not talking
much closer.
I'm not talking about the satellites themselves. I'm saying, like, with observations that we have here on Earth, as far as the sun rising, the sun setting, the moonrise, moon set, the lunar eclipses, solar eclipses, the two celestial points. I mean, all of that stuff wouldn't. Because I'm down with the geocentric ball Earth because. So
you said you had been around for this conversation for a while, like 10 years plus.
Yeah, dude. I've been I talked to Jaron last night. Like, I'm not just
hell yeah. Well, yeah, it's just cool. Like, you came here and like, oh yeah, sunset though.
No. I could go on for days. I mean, we're talking about GPS. Like, I took with Jesse Kozlowski across the Bonneville Salt Flats to actually a $20,000 GPS on my truck, and we went and did because it's a very level and very straight road, because when you're getting the XYZ Cartesian coordinates, it can kind of mess up if it's a windy curve. But basically, we went and across it twice, and we measured. Yeah, we hooked up with Walter Bislands. I'm sure you know who that is, but he actually mapped it out, and we got within 0.5. I mean, I don't know why there's laughter. 0.5% of the Earth's curvature.
Well, cool story, bro. Do you have anything on the topic?
Hold on. Wait. Hold on. hold on. So we'll get a reciprocal GPS angle. What do we know about GPS? What does it do with scaling? Oh, meridian corrections. It's always going to comport back to the globe. They have meridian corrections built into GPS. Now, what that means is the time from when the signal is sent to you, from when you receive it, your device is going to make calculations based on how long that is and the position of where the satellite was when it was sent to you. And it's going to make some corrections and it's going to output you exactly on the globe, dude.
So could you backwards compatible, like, could you like figure out the flat Earth because the Earth is flat? You think? Do you think you could somehow reverse engineer the GPS that makes it into a ball somehow? Do you think you could then find out the true flat Earth?
No, explicitly not. It's a time interval system that's being conformed to the globe based off of the speed of light and how long it took for you to get the signal. So we would have to get their source code, like not the shit that we're like, oh, you can go on GitHub. Like, no, we would have to have like the actual backend stuff, because what was found in the 90s, two gentlemen went to went to Colorado to get some GPS data, like the raw GPS data, to see if the speed of light was the same, and they found that it was already corrected on the back end to give the appearance that the speed of light was the same. And their conclusion was that the speed of light was the same. And the reason that the speed of light was constant, and that they were okay with the corrections already being applied to the data set, because they said, and this is a huge misunderstanding on their part, they said that the Sagnac effect is a second order correction, and that it's not relevant to the speed of light. And it's like, ooh, that's not true. That's a first order correction, and it's explicitly you making a velocity correction to electromagnetic propagation to make it be the same speed, like to make it constant. So
it was really cool, actually, because we got within a couple millimeters. No, I'm saying as far as like, no matter how it works, GPS, however it works on a flat Earth or whatever, we were finding some of the surveying points. I think you might think this is cool because you're a smart dude. We were finding some of the surveying points that haven't been updated for a long, long time. And we actually brought in the GPS units and found them. I mean, these things are incredibly accurate. No matter if the Earth is flat or round, it doesn't matter.
Is your point GPS works?
Yeah, I feel like with the meridian correction, though, it's never not going to put you on the globe within 3% of the curvature or whatever, like 0.00%. Like, it's literally what it's designed to do based off of that.
No, I got you. So, I'm wondering, I've been talking with Jaron. You guys said something when I was listening before about him for 9 years, actually, me and him back and forth. And I'm a Glober, and he's been able to, I mean, I can talk to you guys about what happened on 911. I can talk to you guys about the BS that we went through for the past 3 years, the past 4 years with the medical stuff and the fake medicine that they had at Ready and stuff. I can go on for days about all of that stuff. I just never got on board with this because of the simple observations. And I think Jaron's kind of getting onto that as well, as far as this is our representation. As far as some flat earthers use the AE projection, which is, there's also an Antarctic projection that's centered on Antarctic that will work for his observations if he goes down to bed.
No.
Yeah, exactly. But
wow.
there are two celestial points. And, with him, like, he's going to take some of these observations and it's going to change things, and I'm wondering, like, if that doesn't change, like, would that change anything for you guys if there is a 24-hour sun in Antarctica?
Well, before we move the goalpost to that, and the subject of what Alan was talking about with GPS, and since you mentioned Jesse Kozlowski, it's interesting because he understands about the plane system, the planar system that gets transformed into lat long. So he understands that these are kinematic equivalents where you can get your coordinate system based on just transformation of the coordinate system. And that's in the nest. We like to play that every once in a while as for laughs. But as far as the subject is concerned with GPS, before we go into the Antarctic experiment, which isn't really experiment, it's an observation, understand that there's observations and there's tests. What you're talking about isn't a test. It's an observation, and nothing about that observation proves definitively what you're standing on. No observation of the sky can prove what the Earth is, and that's an objective fact.
To you, your subjective opinion on an objective fact, of course, I'll take that, sure. Anyway, Alan, I don't know what that preamble or premise that guy just went through, but I was wondering, we were talking, do you think that would change anything for you? Because there is a northern, there is a southern, there are two celestial poles, there are equatorial star trails that go over your head. These things are just logically, if you can think in 3D space in your head, this is required on the globe. And then we're talking, see, this guy has to try to.
Oh no, I'm sorry. I did not mean to. I didn't know I had my mic unmuted.
Oh, no worries,
I apologize. I was humming to myself. I'm just listening along. I got you.
Then we have, Kepler, and we have basically the motions of all of everything in the sky as far as in our solar system. And that could be explained on a geocentric ball Earth for sure, with all the observations we see. And it's really baffled me over the years to see such smart people like Jaron, you, Witsit, get locked up in this kind of like we are kind of abductively trying to prove our premise. Like we think that this is the objective truth. Everyone else is just misguided, in all of these scientific fields. Everyone's just such an idiot, all the astronomers, everything. And there's a few thousand people, maybe you guys think it's bigger, on YouTube and X and on TikTok that have continued this for 10 years. And I'm just like, what about another 10 years? Where will we be at? Will we have a map, model, or predictions at all? Will we have anything to show for ourselves for 20 years of this conversation?
Yep.
At that point?
Let's see. So let's back it up a second here. So in regarding to the sun and all that, yeah, I agree. It would put a damper on flat Earth for me until we had a mechanism to show it, like we do with the Southern Star Trails and stuff, right? So we have no fanfare who has a physical demo of how that would work on a plane. And then on top of that, we have, what was the other part? I forget the last thing you asked about. It was, the Kepler stuff. So Kepler is just a proportional ratio to pi when you convert distance over time to pi to get the orbital diameter. So it's just a proportional ratio with that. It doesn't explain anything, right? It's just the periodicity of an event.
It does
proportion to pi,
which we don't have.
No. It makes It makes no predictions. It's based off empirical observation. In the equations, it's based off of periodicity. Periodicity is observing an event.
Mars is going to be somewhere. We can't predict where it's going to be.
You're not listening. It's already observed. Right? It's a proportional. It's a proportional ratio no. It's a listen. In the equation, they use the periodicity of the event. What's the periodicity? When it completes a revolution, right? When it's already been around the sky. When they took a point in the sky, they said, okay, you dot in the sky, we're gonna however long it takes to get back. When you're back in the sky, that's when we'll apply this equation in that same exact spot. And that's what they did for all of those. So when you say prediction and we know where it's at, we know where it's going to be, well, it's based off of a periodicity. It's not a prediction.
So why can't you guys map it onto a flat Earth?
Shane, you want to take that one before I fall asleep or now?
Yeah, but real quick, just so you know where Kepler came from, right? Square the period is directly proportional to the cube of a semi-major action. That's all it is. It's an observation with a coefficient that is a proportionality. So it has a relationship that is universal no matter what you put in there. And that's how you get, Newton's law of gravitation actually just reduced from this as an observation of Kepler's law from Newton's law. So you have mass inserted that way. Anyway, yeah, dude, you mentioned maps. How much you know about maps? What do you think maps project? Let's start there.
I can take a globe and basically through Adobe Photoshop with an add-on, I can make any kind of projection. Stereographic, I can make azimuthal equidistant, Antarctic centered. So basically maps are virtually all projections of the spherical Earth that we live on.
Almost. That's like 81% of the way there, right? All maps are projections of coordinate systems, with coordinate systems are just, grid lines, number lines, Cartesian, and 3D space, but those coordinate systems have based in reality, use datum, With the datum, they have spherical coordinate datums, all WGS84, WGS83, 927, 83, which are geodesic confirmation spherical datums that then get projected in the graticule called longitude and latitude gridded network line. That, of course, is spherical in nature because of its origin being derived from the stars, right? If you're looking at a star, you're taking an angle, you have a bisecting great meridian, also called your horizon, that you're looking at an angle from. You're using a little bit of trigonometry, a little sine, cosine. You're going to calculate a ground position. You're not going to measure anything on the ground. You're going to calculate a ground position based on the angle to the star. That's where the geographic graticule comes from. You guys call longitude and latitude. So that's a spherical baseline. We're going to compare that to the stars in the form of the celestial sphere. We're going to compare the stars to the angles from the stars. We have a 1-for-1 correlation with the geographic graticule to the celestial sphere, mimicking exactly sphericity to sphericity. So when you're comparing those distances, when you're using GPS in the coordinate system, when anyone is ever comparing distances, you're only ever comparing spherical graticule to spherical celestial sphere. There's never been any measurement of the Earth in any of this so far. Anyway.
Besides that very last editorialization that you did at the very, very end, I literally agree with pretty much what you just said, because it's 99% what you just said, mainstream science. You just editorialized it with like 5 words at the end, dude. Literally. That's incredible. I'm like baffled. Anyway, sorry.
That's cool. Which part was wrong?
No, I just said that 99% of the mainstream science that you just spouted was right, but then at the very end you had like 5 words that editorialized it. It's like, so that's what you guys do. It's amazing.
The part that he disagreed with, Shane, is the measuring of the glob. He agreed with you on all the other stuff, but he's saying
from an observational point, whether you're a glober or a flat earther, the observations are all going to be the same. And also, by the way, if NASA was a truly honest organization, they would set aside some money for actual educated, knowledgeable flat earthers like our team here.
NASA would want flat earthers to go into space with them or to launch satellites? What would they need flat earthers for? They don't even believe in any of that.
How about giving us a budget? That's all I said.
Okay. No, I've heard that for years. With Jaren used to say it all the time, like, if I had $1 million, I could, if I had this much money, we could do it. And a lot of times they'd say, well, the flat earth has only been around for whatever, but then they would also under the same breath say that flat earth was before the globe earth theory, which is funny, but yeah.
Well, I don't think it's going to be a choice soon. Like, if you have been here for 10 years, you know that flat Earth awareness has grown exponentially. There's more people that Neil deGrasse Tyson loathes and wonders, hey, it must be a failure of the education system because there's more and more flat earthers every year. So we must be doing something right.
I've heard people say that, but what metric are you using? Do you have any metrics? Because Google,
you can use Google metrics to see the numbers jump. You can use a couple different search. Hey, people are using TikTok for search engines as well too. So, and you can imagine how much millions of hits
have you done that coalition? You've done that collation yourself? You're saying?
Sure. Yes, I have. Yes, I have.
Oh, dude.
And this is in spite of like horrendous amount of censorship. Also,
as well. And also, I did a comparison between relativity and which I'm going to post in the nest soon. What do you think mainstream science, the core elements of mainstream science, do you think that search has been up since then or down?
For relativity?
I'd like to get back to the measuring of the Earth, because that was the part you disagreed with, right? Like, so you agree with everything that Shane said except for the measuring of the Earth. So when they went to go and measure the Earth, they corrected for the stars, dog.
Dude, they never measured the Earth, I said. They just measured the stars repeatedly. And he's like, yep. Wait, you said that's not the Earth, though? I disagree. Okay.
Yeah.
Well, at what point do you think they measured the Earth? When
the
geographic
95% of what you're saying was legit.
Not all of it was legit. You just don't like a little bit of it. Is all.
I don't think you ever said anything you said.
I don't agree with your editorialization. That's it.
Can you repeat the one part that you agree with what he said?
Or the part that you disagree with, instead of just saying the editorialization?
The very ending was where he just like basically nodded it, poo-pooed it away.
Where did I start?
Like, no, Shane, I got you, dog. So
you went all over the map. It sounded great.
The end of what you said, The end of what you said was the measuring of the Earth joke, right? That's where he was like, nah, I disagree, right? So where did they measure the Earth again?
So you were saying facts about mainstream science. Is that not true or not? So you made all of that up? Is that all flat Earth lore?
Where did they measure the Earth again? Because that was the point you disagreed with, right?
Well, I hang out with surveyors, and like I've surveyed too. So like I'm not going to pretend that they haven't surveyed the Earth, right? I'm just not. But go ahead and try to.
So, okay, great. So as long as we're on the same page now, so Shane, would you like to cover surveying, geodetic surveying, and cosmography? No. Hold on 1 second. Would you say your name was Tom? So this is extremely important here because you're like, okay, yeah, graticule, map, spherical. It's all sphere, deriving spheres from the stars. Projection, sphere, project, right? So now we're going to see what happens when they went to go and measure the ground to see if it was also a sphere, right? So Shane, take it away.
Wait, so I mean, like, really, you're gonna defy all the surveying books right now, or what?
No. I'm gonna cite one. Have you heard of McToon?
Exactly. So let's go 95% globe. Go ahead. Let's teach us the globe.
Take it away, Shane.
I thought you were a glober, man. Don't you know all this stuff? That's how you know how dumb
we are. Teach us the globe.
Or wait.
And then editorialize.
10 years, he said 10 years. He doesn't know anything.
Do you know it before or after I say it, though? I'm just curious.
Before what?
Do you know the truth of the globe before I say it or after I say it? Because
the truth of the globe, well, I mean, I have tons of observations we'll have to get into another time at the Great Salt Lake that I would love to show you guys.
Well, that's cool. But if
we can get into it tonight, bro. It seems like you got a lot to talk about. We want to hear about it.
I could go on for days, but we should probably
well, no, honestly, you're pretty respectful. We like having Globers to talk to, so please stick around here, right? Like for the geodetic surveying part, though, if you've ever read the American Arc of the Parallel present on mctoon.net/se, you'll notice the various corrections to the same spherical graticule system that I just said. And they said, oh, this is actually the first time they introduced the corrections to said graticule coordinate system. And that's from they have corrections in the table of contents, right? 733 is where it starts. If you read it through, you got page 623. Observations for the number of star catalogs greatly multiplied because the computations made for the corrections for latitude. 623 again. 734, the interval for a convenient table given by the quantity for the data for the various longitudes. So they do an azimuthal longitude corrections. Again, page 734, there's an extensive template, by the way, we already published on my database. You can go through if you have any questions. You got 837, and again, mctoon.net/the American Arc of the Parallel, page 837. Longitude differences noted for the arc of greatest importance. They have a little measurement here. In the first place, our reference spheroid does not correctly fit the curvature of the arc. So hence, a reference spheroid of smaller dimension and parallel seems to be called for. So they modified their spherical graticule datum, as we said before in the intro, page 837, right back onto, let's go to 838. Oh, when they had the difference, when they had their measurements not comporting to a sphere of the radius for the dimensions required, they threw those measurements out. That's page 838. And page 837, are rejecting all values greater than 8 inches per mile squared. They would reject them back primary longitude for the whole arc value above. And then we go back to page 18 in the beginning when they say again, to going from all the corrections at the first time for all the variations for latitude, longitude. And then of course, page 44, when they, the corrections for this graticule and the corrections for this datum have already been applied. Just a little notation. And if anyone likes to say that they're doing optimal measurements without considering refraction, that's incorrect. Page 206, persistent lateral refraction also has a share in producing the above results. So we've measured the Earth by looking optically through curved lenses, repeatedly measuring to the stars, correcting to the spherical graticule, restricting ourselves to measurements that only comport with the sphere of the required radius. Oh, and to top it off, page 451, this is the general remark, due to the general flatness of the country and the desire to strengthen the connection to the graticule. Anyway, page 451 of the said 451. So if you ever read that document, I would stop citing it as globe evidence of anything.
Does it say anything about spherical excess? What do you have to say about that?
Yeah, he just went over what they said about it. They made it up in the corrections, dog. Did you not hear that? He just listed all of them. Nobody's ever measured spherical excess. It comes out of calculating it based off of deviations from the stars, bro.
And to be fair,
like the whole thing,
and that's wrong. That's wrong to a flat earther. I get that. So we're in a disagreement there. We can find that. That's wrong.
Before I said it.
You can't use the sky for anything as a flat earther. I understand that. Okay. So
it's not what we're saying. We're telling you that the ball was derived from the sky. Right? We're not saying you can't use it. We're not saying don't look at sky. Don't look at sky. No. Look at sky. It tells you where you're at in geographic location and time of year. Right? So
10 years into this conversation, bro, you shouldn't be straw manning.
Right? So
what was
what he just laid out was the insignificance of, oh, well, we went out and surveyed it and measured it, and me and my boy, you went out to the Salt Lakes. Yeah, you just measured a flat
Earth at all.
You just measured a flat Earth,
Again,
and then you're comparing it to a data set that's given to you based off of the stars, bro. You understand?
What data set do you think I'm using when we're doing our observations?
Well, before he said we didn't measure the Earth, he disagreed with that. We asked him, we couldn't articulate anything, right? But now we showed you how all of the actual geodetic surveying repeatedly corrects to the data set from the stars. So still, we have non-Earth measurements.
That's not, bro. Don't you understand? That's not incorrect to me. You're reading mainstream science. I don't understand how you guys what the major malfunction is here.
You're not understanding how it undermines.
You might as well get a globe book and read it to me and be like, "But that's wrong."
You know what I
mean? The globe exists in your eye, not on the ground, though. Do you understand that? That's literally what we're putting forward. Right? So, that's what they went out and measured. That's what they made their coordinate system based off of. That's what they're mapping everything off of. Yeah. That's what it all comes from, right? The curvature of your eye.
Correct to you, but not to me. We got to get past this. Okay.
Curvature of your eye.
So there's
you have to get past it, bro. You're the one, bro. You have to get past it. You came here.
So no. So I mean, you just deny it, though. Rhetoric. You guys deny millions of images and videos from space too. You deny everything that you have to conform to the flat Earth belief. That's okay with me. I've been around you guys for 10 years. I have a conspiratorial mind too.
You haven't been around us for 20 minutes, bro. Otherwise, you'd be acting different.
Right.
You're all the same. It's all the same.
We're specifically talking about where your globe
fails a religious belief. Now. It's a religious belief. You guys can be shown any amount of evidence, and you're just going to stick to your flat Earth, even though you have no evidence. You just read.
Well, we understand that. We understand you have a script, and this is more for the audience to demonstrate what an anti-flat earther, the person who's talking to them, the anti-flat earther versus a globe earther. As the audience knows, the person who is talking.
Invalid. We talk over people.
I don't think he can hear me. I'm gonna come back.
Invalid. Xavier, can y'all hear Proud?
Oh no, I didn't hear. I heard him over talking everybody, so he might have been over talking, and I couldn't hear Proud, but I heard somebody say come back. I don't know.
I'm gonna bring Proud back up. Go ahead, Xavier, and then I'll let Invalid respond, and then we're gonna get to the things that he knows, because every time that we're explaining things, he just calls it words, and he can't really articulate a refutation to those words, and he's dismissing it. And I don't really like that approach. So go ahead, Xavier. Keep cooking.
The last thing is I'll sum it up in this. While he said it, Xavier, I'll sum it up in this. He said he went out with Jesse Kozlowski, and we were talking about GSPS at the point. And I put up a video and I put it in the nest how Jesse Kozlowski himself admits that GPS operates on a flat Cartesian plane. They have to transform it into lat long of a globe. That is demonstrable. That undermines his specific claim when he came in to talk about. Now, I appreciate him just running off a script that he has memorized, because it shows the audience the difference between an anti-flat earther, which he is, and globers who engage in honest discourse, like the young lady who was here earlier. So we engage, we match the energy, but we also will give evidence that is relevant to the conversation that he will dismiss. But this is for you, audience. It's not for him. We know he'll dismiss everything that we say, but I understand the evidence when he asks a question, what is brought up.
Actually, the audience can remember 5 minutes ago when I agreed with the globe science the guys told me, right? So when you guys come on and have these premises like, oh, he's just here to do this and that, it doesn't, they're listening too, okay? Maybe you're not listening to our conversation and you just want to come in as if I'm some enemy of yours. But it just doesn't make sense anytime Xavier talks. I'm sorry.
Invalid. How many times have you spoken to any one of us? Is this your first time?
I don't. Dave Weiss is in the chat. I've talked to him, but no, you guys are new, quite new to the flat Earth.
So why would you, if this is the first time that you're speaking to us, why would you tell us that we're just gonna dismiss everything that's presented to us? Like, why would you say that if this is our first interaction? Isn't that a bit incoherent if you've never had a conversation with us before? Wouldn't you agree that that's logically bankrupt to say something?
To be a flat earther, let me just, for one example.
No, don't categorize me. Don't categorize me. You say you guys are just going to dismiss any evidence or information presented to you. So I asked you, did you ever have an interaction with any one of us up here before? Yes or no?
I already answered that.
And if you didn't, is that logically bankrupt to make that claim if you don't know us like that?
No, because if you believe in the flat earth, then you do not believe in any of the millions of video and pictures of the earth from space. There's Himawari out there that's taking a picture every 8 minutes. Has to be fake if you're a flat earther.
Oh, it doesn't have to be fake. They actually told us that it was. You said that you spoke to Jeranism. You spoke to Jeranism. Jeranism did a whole YouTube live on the Himawari 8. He broke down all the different data that they get from the Himawari 8 and how it's all projected images, how they have the whole framework in these files that you can go like just download yourself. Like,
so you can't see the cloud.
So have you seen that from Jeranism since you're familiar with Jeranism's work?
I remember that, and we actually talked about that because there's been a time where there's been fires and things like that you can actually go to Himawari and see the smoke in the air, right? So maybe the wireframes and the conspiracy goes that far where they have, and really it wouldn't even be that far. You would need probably several planes taking images, and you could wrap it around a globe. Sure, it could be fake, but back to the point, flat earthers have to basically believe that all of images of the Earth from ISS, from everywhere, even though Jaron did transits of the sun and the moon using globe Earth math to see the ISS transit, it's very ironic that you guys continue this, truthfully.
Yeah, well, flat Earth isn't. Hold on 1 second. One second, Liliana. 1 second. I'm gonna let you go on. So flat Earth isn't a belief, right? Like, we actually went to go observe where they say the curvature is claimed to be, and there's no curvature there. But when you say, "Oh, I've been in this conversation for 10 years," and you bring up the Himawari 8, and you know that they have pre-programmed data sets, because you actually spoke with Jeranism about it and you're just dismissing that, what does that say about your approach?
So that didn't address the fires and the other events that happen on that side of the earth, Australia and Japan and stuff. They're looking at Japan, they're from the sky. So did you dismiss then being able to actually look at things that are actually happening on Earth? Or they just generate? I mean, really, it could be fake, sure. But that's just Himawari. There's millions of images and videos of the Earth. They all have to be fake because it shows a globe Earth.
Well, they actually came out and said that they were, Doctor. They come out and said that they haven't have a full.
Who did? Who came
out? Robert Simmons is one of them.
Does he fly did he put the Himawari up?
Did you?
Well, no, you're making claims here.
No, you brought this up. This not our claim. You brought this up. So why would you sit there and say that I'm making claims if you're the one that brought this up?
We're getting off on a tangent. It was first about
we're addressing this with specifics, bro. No, we're addressing with specifics. I know you want to categorize it as a tangent because you can't like spin me because I'm like completely on topic.
You're having two different conversations.
Well, we have to keep up with all of your goalposts that you're moving. Right, like they started talking about a different topic at first. You said it was just words. They were trying to explain it to you, and you didn't have any refutation. And then you started talking about like sunsets and moons and space pictures.
Now we're going on to a different
after you just said everything that Alan said was just words. So it's just like I don't even know if you're even retaining any of the information, which is why Shane was prefacing what he was saying.
Scattergunning it. So I don't even know what
all you're doing right now is you're interrupting me as I'm highlighting your incoherency, bro. So we're trying to figure out like we're trying to figure out if you have an honest approach or not. Because that's why when Shane was talking, he's like, "Hey, how much do you know about this before I'm about to say it?" And you didn't say, "Well, I know this, I know this, I know that, I know this." You didn't say anything.
I've been around for 10 years.
And he went through, you went through 10 years and you're talking about the Himawari 8. It's like you should know, like that whole thing is.
Why did I bring up the Himawari 8? The thing we were talking about. You remember what we were talking about?
That's not what we were talking about. We were talking about.
Remember what we were talking about?
We were talking about so many different things. Listening to you because you want to stay on. Well, you want to stay on topic. We were talking about.
No.
you brought up spherical excess. You brought up space photos.
Okay, that was a while back.
We're talking about atomic clocks and gravitational length.
That was a while back.
Fields. Yeah, all those different things we were speaking about, and you didn't refute any of them. You didn't refute any of them. All you just said was, "Oh, no, it's not because. It's not a because."
They're saying
no. I know you want to talk through me. You didn't refute any of them. Period.
Because it's mainstream science.
It's not a because, bro. You just didn't refute it when you had the opportunity to do so. What you did was you went to a different topic. And since my guys are cordial, they followed you into the next topic and presented more information. And then you just said, oh, 99% of that I kind of agree with. But then you just editorialized the ending. And then they said, well, what part? And you said, oh, the end.
Is this a meta conversation you're having?
And then you didn't add any
summary you're doing of our conversation?
Yes, I'm doing a summary of everything.
Yo, is this Black Wolf?
Almost. It kind of seems like it. Bro,
dude, it's literally Black Wolf, bro.
Let's like meta conversation our conversation again. Hey, can you tell me what I said?
It's the Jewish version of Black Wolf,
but
bro.
You're not refuting. You're not addressing anything. All you're doing is categorizing us. All you're doing is categorizing us and making baseless claims. You're making baseless claims, and you never even had a conversation with us. I didn't come up here and judge you and say anything to you. As a matter of fact, Xavier did a phenomenal job highlighting the difference between you and the prior globe earther that came up here. The prior globe earther came up here. The prior globe earther that came up here had real questions and then actually responded to the things that we said. You're doing the complete opposite. You're just categorizing all of us into one group.
Meta this conversation?
Yeah, this is my space. Yeah, this is my space. I'm gonna continue to talk as long as I want to, bro.
Yeah, continue.
You're lucky that you got a mic up here, and I didn't like say anything this entire time. I let you go back and forth with my boys to see if you had any type of value to add. You added zero. As a matter of fact, so much so you were about to give a reason why you added zero value. I don't care about your reason of why you added zero value. You just didn't add any value, period. So it's like, are you like trying to approach this conversation with honest approach, bro? Or are you just trolling? We're trying to figure this out. We should waste any more time on it. So wait, now I give him the mic, and now he talks through me the whole time. I finally get to the end of what I wanted to say after being quiet for how long? For like over an hour and some change. And then this man decides to leave. After I highlight everything that has happened over, I don't even know, past 30 minutes he's been talking. It is weird, bro.
Been in the game 10 years, dog, or whatever.
Yo, you guys don't know who I am? You don't know who I am, guys?
I literally
forgot about that. The ego. You don't know who I am. No, bro, we don't know who you are.